Okay, so let's take a look at Chapter 7a, number 6. And in this one, what I've done before even starting the proof here is on the side I've listed off the ways to prove triangles are similar. And at this point, we've actually only talked about one in class. That's this one. So we're going to have to use angle-angle similarity. So prove two sets of angles are equal, two corresponding pairs of angles. And then just for reference here, because this is going to come up too, after you prove triangles are similar, then you're allowed to use either this or this, which is a lot like the CPCTC for congruent triangles. Okay, so let's take a look at what we have. The given is 1 and 2 are congruent. So I also drew the small triangle here, right here, and then the big triangle right below it. So you can kind of keep track of both triangles without having to overlap the pictures. So the first thing that we can do is angle 1 is congruent to angle 2, and that's given. So statements, reasons. So 1 and 2 are congruent there. And so right away, this actually gives us a pair of angles. Right? I already have one pair of angles matched up. So all I need now is a second pair of angles, and I have angle-angle. So if we keep looking at the picture, if you notice right here, well, angle B is shared by both triangles because it's right here and it's right here. So I can say angle B is congruent to itself, and that's just reflexive. So here's my second pair of angles now, right there. So now I've got both pairs of angles, and I can then say, okay, now I've got this, angle-angle. So step 3 will be that my triangles are similar. DEB is similar to, in this case, CAB, because of angle-angle similarity. Okay. Well, now let's take a look here at, now that I have similar triangles, what I can do is I can kind of color code them. Like EB in the small triangle is going to, whoa, EB in the small triangle, right here, is going to have to go with AB in the big triangle because they are both between the one curve and two curved angles. If you look at DE, it's connected to the angle that has one curve on it, so that's got to go with CA. And if you look at our last ones here, I'll do these in red, DB is going to go with CB then. Okay, so I've got the three things matched up, and they're easy to see now. What I want to do is I want to look at what we're trying to prove. The goal is to get this. BD times CA equals BC times DE. Okay, well, BD, if you notice, that's right here in red. And so what I'll do is I'll actually circle this one in red. And if you look at, let's see, CA, that one's in green right here. So I'm going to circle that one in green. So here's CA in green. If you look at BC, that's in the big triangle and that's in red. So I'm going to circle that one in red. And then DE is in green in the small triangle. So I'm going to circle this one in green. So what I got to do is somehow figure out a way to get these reds and greens together. And if you look at what you're allowed to do after you have similar triangles, you're allowed to match up the angles according to this one, or you're allowed to set up sides in a proportion according to the second one. So that's the one that we're going to aim for. We're going to set up sides, because if you look at the thing we're trying to prove, it only deals with sides and no angles. So we've got, we need to set up a proportion. And if you look over here, I only used red sides and green sides. So I'm going to set up a proportion that only uses the red sides and green sides. So one of the sides here, one of the proportions I could set up would be the little green over the big green equals the little red over the big red. So if I set that up, that's DE over CA equals DB over CB. Okay? And so that's because I've set up corresponding sides of similar triangles in a proportion. Okay. Well, if you look at this, if these were numbers right here, usually what people tend to do from algebra is cross multiply. So let's just do that, because that's what we've been doing in class anyway. So if I cross multiply, I get dB times CA equals DE times CB. Actually, I'm going to switch those around. CB times DE. It doesn't really matter if you switch them around or not, though. And that's because I cross multiplied. Okay. Now, if you look at that, I'm going to highlight this right here. DB right here is the same as the BD way up here. Right? That's the same thing. And CA right next to it, this CA is the same as that CA right there. So this side of my equation is set. And if you look at the other ones, it's BC and DE. Well, that's the same as CB and DE. So this line, line 5, is actually the thing that I'm trying to prove. So I'm done right here.